So, good afternoon, everyone. Today, we are going to see the very important topic. Topic name is digital root. Okay, digital root, or else we can call it as beejank, Sanskrit, or casting out of nine. So, we can call any one of these names the method. Okay. Actually, before going to see this method, let us talk about the general um, problems related to calculation. Suppose, let me take here one example. Suppose 27 I taken, okay. So, and I'm adding like 18 to this number, then I got here 45, okay. This is a general addition, we know that. Suppose, if I'm dividing this number by 9, then I have to balance the same number, we have to divide the right side also, yes or no? Then it will be balanced, yes. Whatever number you can divide or you can multiply to the left side or right side. Let me take suppose left side and right side. If you take like this, okay. Suppose if you are multiplying right side with 5, then you have to multiply this also with 5. Suppose left side you are dividing with let it take 8, then right side also we have to divide by 8. Then only it will be balanced. Otherwise, it is not balanced. Okay. So based on this concept, we are going to see the digital. Okay, we are going to the digital root. Suppose if you're dividing this number that totally we are dividing 45 here. If you divide individually, you divide this number, then your remainder is 0 here. If you are dividing this number, your remainder is 0 here. If you add 0 plus 0, totally we got the remainder is 0 in this case. And the same number, if you are dividing this number, then also we are getting the remainder 0 here. Are getting my point? So both side we have the remainder same. Yes or no? Let me take another example. 15 plus 14 that equal to 29 I taken. So I'm again dividing with 9 here, and this is also I'm dividing with 9. Then you can see here remainder will be 6, here remainder will be 5, and here remainder will be 2. Yes, 6 plus 5 divided by 9 is there, and 2 by 9 is there. Okay, still it is not solved. So 11 by 9, 2 by 9. So if you're dividing this number, then you are getting 2 remainder only. If you're dividing this again you are getting 2 remainder. So both remainder are same. Yes or no? Why? Because both remainder same. Because of we are using the equivalent symbol in between there. That is the reason both are same. So that is the reason we are developed a digital root concept for the verification purpose. For the verification purpose or cross-checking the solution. This purpose, we are developed this digital root concept on the 9 only. Why we are developed on the only 9? What about remaining digits? See, 9 have the special property. It has a special property. That means if you 2, 4, 5 is divisible dividing with 9, then you can see if you solve it in a general method, so 9 2 jars 18, 18 subtracted and 65 I got, and you can take 7 times 63, and if you're subtracting, then 2 will be the remainder. But if you see the divisibility rule of 9, the divisibility rule of 9 says that adding the digits of the given number 2 plus 4 plus 5, okay, then it gives us 11. Yes. Again, if you add it those digits 1 plus 1, then you are getting 2. So without division also we can find the remainder. How we are find the remainder? By using divisibility rule of the 9. So it is possible for only 9, not other numbers. If you apply and the same condition, same rule, it is not works. Only 9 have the special character. It has special nature, its own nature it is have. Okay, are getting mine. So that is the reason we are choosing 9 here. Okay, let us enter into our concept now. So what is, we can say that it is digital root or digit sum also we can call it as. What we call it as digit sum. Okay, why? Because we are following the divisibility rule of 9. What is the digit sum or beejank, whatever you call? What is the procedure is there? Let us see. For suppose 24 is there. Okay, 24 is there. If you want to find the digit sum, Okay, digit sum I'm indicate with DS. If you want to find the digit sum of 24, then simply what we are doing here, adding the given digit, then we must get single digit number. In case if you are not getting single digit number, again we have to find the digit sum of that number. So the digit sum here 6 now. Let me take another number, digit sum of 259. So 2 plus 5 plus 9. So we are getting here 16. So it is not a single digit number. So again find the digit sum of the 16. So then we are getting 1 plus 6, that is equal to 7. Now this is the digit sum of the 259. Let me take another example, 2, 4, 8, 5, 6. This time I taken very large number. So we want to find the digit sum of this number. So simply we are adding 2 plus 4 plus 8 plus 5 plus 6. Then you can see now, this is 10. This is 10, total 20 plus 5, 25 we got. But is it not a single digit number? We want single digit number. So again, we are finding the digit sum of the 25. Then we are getting 2 plus 5 is equal to 7. Now 7 is the digit sum of the 24,856. It is clear to everyone? You have any doubt, you can raise your hand now. In the chat box, we have option to raise your hand. So you can raise it. It is clear? Then I will move to the next step. Anybody have any doubt?
No, sir.
Yeah, that's good. So in this way, we are finding the digit sum. Okay. And remember one thing, that digit sum is nothing but reminder when you are dividing with 9. So if you take 24,259 to 24,856, if you divide with 9, this remainder you will get. Is clear my point? So the digit sum and the remainder both are 7 in this case. Okay, right. But some difficultiness is there. Okay, some difficultiness. When you are taking very large number, and if you are going to find the digit sum of that number, it will be take so much time. Yes. So this will be 10. Okay, 10 I got. After that, this will be 11 and this will be 14. So total I got 35. Again, we are finding digit sum of this number. So then get 3 plus 5 is equal to 8 I got. So the digit sum of this number will be here 8. See, it will be take so much time to find. So for that, we are using here casting of 9 concept. Okay, casting of 9 or casting out 9 concept we are using in this. Suppose let me take one number 24 I take in. So what is the digit sum of this number? Come on. Just know Visa. What is the digit sum of this number?
6, sir.
Yeah, 6. 6 is the digit sum. Okay, that's good. Suppose I'm taking 24, I'm adding 9 to this number. Then I got here how much?
33.
33. Now find the digit sum of 33.
6, sir.
Any changes there?
No, sir.
Let us try to solve same problem. Subtract 9 from this number, then you are getting 15. Then what is the digit sum of 15?
6.
Again, any changes there?
No, sir.
So the point is, if you adding 9 or 9 multiple, why I'm saying 9 multiple, I will tell you later. Okay, what I'm saying, when you are adding 9 or 9 multiples to the given number, digital root remains same. But when you are adding the 9s or multiple of 9s to the given number, then what happened here? Number will be increases. So that is the reason I am not going to add 9s here. Okay, sir, are you there? Sir?
Yes, yes.
Yeah, somebody asking to join. So can you let him join?
Yeah, I have, taken. Who is that? Who is asking to join? Okay, yeah, I have taken him.
Yeah. So, but when you are subtracting 9 from the given numbers, then your number is reduced. So when number is reduced, then we can easily calculate the digital sum. So when you are removing the 9s from the given number, so that is the call, it is a casting of 9. That is the reason it is a casting of 9. So now instead of adding all the numbers, we are eliminating the 9s, or if you're adding any 2 or more numbers, their sum is 9, even though we are eliminating those digits. Why? Because their sum is 9. Okay. And another very important point here I'm going to discuss. Suppose 9 into 5, 9 into 7, 9 into 101. I taken few examples here. You can observe 9 5s are 45, 9 7s are 63. 9 times of 101 will be 909. Now, if you find the digit sum here, then 9 it will be, here digit sum will be 9. Here digit sum will be, you can see now, digit sum first we got here 18. Again, we are finding digit sum of this number, then you got 9. So what you observe from this example? What we have observed, when any number is multiplied with 9, any number is multiplied with 9, you can take any large number. In case it is multiplied with 9, then their digit sum always 9. So there is a no need to find that. The digit sum is always 9. Yes. And another very important point here I'm going to discuss, that is also very important. So the digit sum is nothing but a remainder. Yes. Yes or no? Remainder when you are dividing with 9. Yes or no?
Yes, sir.
So what
Yes,
happens if you're dividing any number with 9, then you can see here remainder is 0. Remainder is 0. But if you find the digit sum of the 18, that will be 9. Did you observe the point? Whatever I'm saying here, what I said, every digit sum is a remainder. Okay. But in this case, you can see that a remainder is 0, but digit sum is 9. Then our statement right or wrong?
Wrong, sir.
But if you divide again this 9 with 9, then you are getting remainder is 0. So in the digit sum, 9 is equivalent to the 0. Note this point along with that. Okay, these 2 points are very, very important. Why? Because in many areas we are going to use those concepts. Okay, right. Let us see how to eliminate the 9s from the given number. Let us check out. Okay, for suppose 2, 4, 5, 6, 7, 8, 9, 6 I taken. I want to find the digit sum of this number. If you add it, it will be take so much time. If you see 2 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 6, I said. Yes or no? Suppose if see, I said 9 or 9's multiple, I said. Yes or no? Did you remember? If you
Yes,
add
sir.
9's, suppose this is nothing but 9 plus 9. This is nothing but 9 plus 9 plus 9. Yes or no? So now you observe very points. So if I'm subtracting 9 from that, then also digital would never change. So this 9 is cancelled out. Suppose I'm subtracting another 9. You see, 7 plus 2 is 9. Positive 9, negative 9 is cancelled out. Suppose another 9 is that I'm subtracting, then positive 9, this 9 will be cancelled out. Yes? Up to this is clear to everyone? Any doubt? No doubt from anyone?
No, sir.
Suppose if you are adding another minus 9. Adding another minus 9 is nothing but subtracting 9. It means. Okay. Suppose take this number, split this number 5 plus 1. Why? Because 8 plus 1, how much? 9. So that is the reason I split it 1 plus 5. Then this 9 is cancelled out. Yes or no?
Yes, sir.
Then I left with only 5 and a 6. So 5 plus 6 is equal to 11. Again, you add the digits of this number, then you are getting 2. This is a general concept. We have to understand it. But we are not going to solve like this. We are not going to solve like this. Okay. We are going attacking directly here. See, 9 is cancelled. Yes or no? Now you understand why 9 cancelled? Why? Because we are subtracting 9. So 5 plus 9 is cancelled. 7 plus 2 is 9. It is also cancelled. Now, if you want to cancel 6, then how much we require to add to this? How much number we want to add to this number? Then it will be eliminated. Can you tell me?
3.
Yes,
3,
3.
sir.
For 8,
1.
1.
1.
So now I am taking 3 plus 1, then totally 4, and 2 is the remainder. So this 3 I am adding to this number, then it will be cancelled out. And this one is I am adding to 8, then also it is cancelled out. Okay. Finally, I got 2 only. So this is the digital sum of the given number. It is clear?
Yes, sir.
So let me take very large number, suppose like this. So see, 9 is cancelled out. Okay. 6 plus 3 is cancelled out. 9. 4 plus 5 is 9. Cancelled out. 6 plus 3 is cancelled out. Yes. Now can you split this number 1 plus 1? 8 plus 1 is cancelled. 8 plus 1 is cancelled. Yes.
Yes,
So
sir.
finally I got 6. So the digit sum is 6 now here. It is clear?
Yes, sir.
Yeah.
Yes,
I will
sir.
give only 2 examples and tell me what is the answer in the chat box. Let us see who will give the first answer. Come on. Find the digit sum of this given number. See, first we will learn the concept. After that, how to apply for the problems. Let us see later. Before that, we will master the concept. Yeah, many members are sending 2, 3, 2, 3. Yeah, let us check now. Observe carefully. Let us see how I am going to solve this problem. So 9 cancel. Now see, 3 plus 7 plus 2, that is 9. So these 3 numbers also cancel. So only 2 is left. So 2 is the digit sum now. So come to here, 9 is cancelled. 9 is cancelled. So I'm left with 3 here. So this is the digit sum. I hope everyone is understand this concept. I am now moving to the next concept. Very, very important concept it is. Suppose if you see x plus 8 is equal to 56. Then what is the x value?
7. 7.
Yeah, x value is the 7. So we are going to find the value like this, 56 by 8. But we are not going to dividing that. We are finding the digit sum of the numerator. So that is 11. 11 is nothing but 2. And digit sum of the 8 will be 8. So here fraction will become. Yes, here fraction will become. So we are not dividing. We are finding the digit sum. So focus on it. So for that, what we have to do when the divide, when the fraction will become, so we are maintaining the numerator as a 1. Then only we can find the digit sum of the fraction numbers. Okay, for that, what I am doing here, 2 and 2 upon 8 is there. So here I am multiplying the given number with 8 and numerator also 8. Then I got here 16. Here I got 64. Then if you see the digit sum will be 7. Here digital sum will be 10. So again we are going to solve this. Then we got 1. So finally we got 7. Are you getting my point?
Yes, sir.
Without dividing, we have to find the digit sum. So this is the smaller number. The smaller number is always a very large answer. Why? Because steps are very important. If you learn the step, then you can easily solve it. Actually, suppose x into 9 is equal to some 81 is there. Okay, 81 is there. Then, not 81. Let me take here 7. Okay, and 14 is there. So we want the digit sum. So 84 by 7. So digit sum of this number will be 12. 12 means 1 plus 2, that is 3 by 7. But we don't know still digit sum. Then we have to multiply this number with 4 and this number with 4. Then it will be 12 and this will be 28. Now see, this will be 3 and this will be 10. 10 is nothing but 1 plus 0, that is 1. Now digit sum will be now 3. Digit sum will be now 3. Are you getting my point? So for that, I will give one table. You have to master the table. Then you can easily, when a fraction number will come, you can easily solve it. Okay. So I will give one table to you. Okay. Now see that first number is, suppose if your denominator, here I am writing denominator. Suppose if your denominator is 1, then you multiply numerator and the denominator with 1. That is the first point. Suppose if your denominator is 5. 5 means ending with 5 or 5, whatever number. Okay. So in denominator is 2, then you have to multiply numerator and denominator with 5. Suppose if your denominator is 5, then you have to multiply with 2. It is a vice versa. Okay. It is a vice versa. This is the vice versa. Okay. Right. Suppose if your number is ending with 4, then you have to multiply with 7. If your number is 7, then you have to multiply with 4. Vice versa. Suppose if your number is ending with 8, then you have to multiply with 8 only. So this we have to master it. Okay. It is clear my point to everyone? So 2, 5 and 4, 7 and 8. Suppose 3 by 2 is given. Then we have to multiply this number with 5, this number with 5, and 15. 15 is nothing but 6 by 10 is nothing but 1. So the digit sum is equal to now 6. It is clear to everyone? It is clear or not?
Yes, sir.
Yes, sir.
Yeah, please note down that box.
Yes, sir.
Let us see some examples, applications of this digital root. It is very, very important. Let me take a few examples for you. Okay. Can I go for examples?
Yes, sir.
The first example, let us see. So these are the competitive examination questions, and you can use it in your school and colleges also. The same technique. Or suppose 4, 3, 7, 5, 1 plus 2, 5, 6, 5, 3 plus 3, 5, 4, 3, 3 plus 2, 5, 6, 7 plus 3, 4, 2. And answers are 107546. And the second answer will be 106646. And your third answer will be 107846. And your fourth answer will be 107746. It is clear my point? In generally, if you easily add the given values and you can easily find, but it will be take around 1 to 2 minutes. Instead of that, we are using now digital sum. We are using now digital sum. Now let us see how to find the digit sum of the given number. You can see now, this is the 4 plus 5 is 9. I'm cancelling out and I'm giving 2 here. Then this is a cancel out. Only 1 is left. 1 plus 1 is 2. Digit sum is 2. Here you can see this is a cancel and 2 plus 10, 12. 12 is nothing but 3 is a digit sum. This is the 4, 5 cancelled out. Remaining 9 I got. 9 is nothing but we can take 0 also, I said. Okay. And this is cancelled out. 11 is nothing but 1 plus 1, 2. Here you can see 9, that is 0. So totally we got here, you can see 2 plus 3, 5 plus 0 plus 2 plus 0. The totally it is gives 7. So the digit sum of the left hand side is 7. Then right hand also must be 7. Yes or no?
Yes,
So
sir.
let us see
Yes.
which answer give exactly 7 as a digit sum. You can see now this is 9 cancelled out. 13 plus 1, 14. 14 is nothing but 5. So this is not the correct answer. You can see here 6, 6, 6, 18. 18 is nothing but 9. So all the number are cancelled out. So I got 5. So this is also not the digit sum. Come to here. 1 plus 8 is 9. Cancelled out. So I can split this number 2 in 2 plus 2. That is cancelled out. So I left with 8 here. So this is also not a answer. Come to this one.
Answer 4.
So here you can split this number 2 plus 2. Then this cancelled out. This number also cancelled out. Finally, 1 plus 6, that is the 7. So this digital root is matching. So my answer here now will be 4. It is clear, yes or no?
Yes, sir.
Yes, sir.
Let me take another
sir.
example and try to understand that.
Yes.
Suppose 937 whole square. So options A will be 877969, and the option B 834569, the option C 867969, the option D will be 887669. Now see, the digit sum will be here of the brackets. 9 is cancelled out and 10 is nothing but 1. So digit sum of this number is 1. But above we have the square, so we have to square it. So that is nothing but 1 is the digital sum now. Let us see which number having digit sum as a 1. 9 is cancelled out. Okay. So we can give 2 9s. 2 from this, then 2 is left here. Yes. And 10 is nothing but 1 is the digit sum here. Come to this question. 9 is cancelled out. 9 is cancelled out. 17 is nothing but 8. 9 cancelled out here. So now you can give, let me solve like this. 12 plus 7, that is 19. 19 is nothing but 1. 1 plus 8, that is 9. Okay. This is 1. 9 is cancelled out. 1, why? Because 12 plus 7 is 19. 9 is cancelled out. Only I left with 1. That is the reason I'm taking 1. 1 plus this number is cancelled out. I got 8 now. Now, which answer is exactly matching? Option A is
A.
exactly matching. So our answer is 1 now. That means A now. Okay. Let me take here another example and try to solve it. Okay. And this trick is not useful for approximation. Only the exactly value when they are given in the examination, then only we have to apply this. For suppose 88% of 370 plus 24% of 210 minus question mark is equal to 1118. Then we have to find the question mark. Question mark will be 318, 260, 80, 256, 258. So we have to find the exactly answer. So now see, children's, of means multiplication. Of means multiplication. Okay. So we are not bothering about percentage. Percentage is nothing but 100. Digit sum of 100 is nothing but 1. So that is the reason we are not bothering about 100. Okay. 16 is nothing but 7. Here 10 is nothing but 1. Here 24 is nothing but 6. It is nothing but 3. Then question mark is equal to 9 cancel out. Only 1 I got. So 7 into 1, the plus symbol is there, plus 6 into 3 minus question mark is equal to 1. Yes or no? Now see, this is 7. This is 18. 18 is nothing but 9. 9 is nothing but 0 minus question mark is equal to 1. So 7 minus something is equal to 1. Then what is the something value?
6, sir.
6.
Yes, something value is nothing but 6. That means the number which are given in the option, which number having digital sum is 6, that will be the correct answer. 9 is cancelled, 3 is left. Yes. Here
Yes.
7. Here 6 we want, am I right? Yeah, this will be 16. 7 is completed. 7, 13. This is 4. 10 plus 5, 15. 15 is nothing but 6. So this is our correct answer. So remaining options are eliminated. Clear my point to everyone?
258.
Yes, sir.
Yes, sir.
Yes, sir.
Right. Let us try to solve another problem. For suppose 113 into 114 minus 127 divided by 23 is equal to question mark minus 100. Options I will give later. So digit sum of this number will be 5. This will be 6. 5 into 6 is nothing but 30. 30 is nothing but 3. Yes or no? So 3 minus, in this case, 1127 by 27. We are not going to divide it. We are finding digital sum. So this 7 plus 2 is 9. So 2 is the digital sum. Here I got 5. When denominator is 5, which number we are using? Come on, see the table and tell me.
2, sir.
Yeah, so multiplying with 2 and multiplying with 2, then we are got 4 directly. So digit sum is 4 now. So that is equal to question mark minus 1. Isn't it? Now, see what happened here. Minus 1 we got. Minus 1 we got. So minus 1 on the same side we have the same symbol. So the digital rule will be now 0. So let us see the first option. 12743, 12823. Next one will be 12933, 12464. These are the options. Now see, 9 is cancelled, 8 here. Here you can see 9 is cancelled, 7 is the digital root. 9 is cancelled, 6 plus 3, this is 9. Here you can see now, this is 10. 10 is nothing but 1. This is totally I got 8 now. Now which answer is correct now? Which one?
The third one,
Mm.
9.
Yes, third one. Why? Because I said that 9 is equivalent to the
0.
So now our
0.
option
Sir, but
3
their
will be the
digital root would be 0, I guess. Because 9 is cut in 3 plus 3, 6. 2 plus 1, 3. 6 plus 3,
Yeah.
9. So 0. It would be
yeah.
0.
No, it's 0, but I'm not eliminate the 9. I'm writing as it is. Why? Because students sometimes maybe do that also. That is the reason I'm not taking that. Okay, clear. Any doubts so far? Anybody?
No.
And another very, very important, what is that? Problem I'm going to take here, a very, very important one, and it will logically also. 1 plus 90 plus, so 90 into 91 into 92 into 93 is equal to how much? The options are 8371, 8721, 8341, 8231. Is it clear? Right. I told you, when you are multiplying any number with 9, their digital sum how much? What is the digit sum?
9.
9 only. 9 is
9.
nothing but.
Equal to 0, sir.
So now see, here I am using that logic. This is totally multiplication. Am I right? This number is nothing but 9 into 10 into 91 into 92 into 93. Yes or no?
Yes.
So this whole number is multiplying with 9. So the digit sum is here now 0.
It's equal to.
So now you see, can I admin him? Nishita.
Actually, I don't have her name, so I cannot admit her. I do not have the name in my list.
Now see. So the square root of 1 plus digital sum is 0. Totally I got 1. But see, still I'm stopping there. I'm finding digital sum of given numbers here. 9 is cancelled, digital sum is 1. Okay. Here 9 is cancelled, digital sum is 9. Here 9 is cancelled, digital sum is 7. 9 is cancelled, digital sum is 5. So what is the value of here? 1. Here also we got 1. But that is wrong. Why? Because so digital root of 36, if you are finding, that is nothing but 6 only. Yes or no?
Yes, sir.
Now
Yes, sir.
digital sum of this number will be root 9. That is nothing but, sorry, not root 9. Yeah, 9. 9 nothing but you are getting 3. Or else you can take root 0, then you are getting 0. But here answer is not matching. Did you observe?
Yes, sir.
Yes, sir.
But remember one
Yes,
thing.
sir.
36 is nothing but
No, sir.
square of this number. 36 is nothing but square of this number. Then you have to square it. Otherwise, your answer is wrong. Remain simple point I'm saying. When any number is under root, then you are getting some answer. You are not going to taking the answer as it is. You are taking the square of that answer, then only it will be correct. Note this one. Simply, this is a statement. Okay, this is a statement I'm giving to you. If you are finding any value of under root, then you have to find the square of the answer also. Suppose root 49 is there, answer is 7. But for the digital root, you have to find the square of that number. Then only your digital root is matching. Here, digital root of 49, we are taking only 4. Then finding the square of this number 49, then you are getting 4. We are not going to find the root value. We are not considering the root value. We are considering the middle value. The middle value is nothing but square of the 7. So we have to find the square of that number. Clear my point? Let me explain you once again. The same point I am repeating. The square root of, suppose 2304 I take it. Now tell me, I am finding the digital root of this number or the square also. I am finding the digital root of this number only. This is nothing but square of some number. Square of some number. That will be 48. This is the answer. So the digital root of this number will be 0. Here digital root of this number will be 12, 3 square. That is nothing but 9 is equal to 0. Now it is matching. Now it is clear my point what I am saying. It is clear or not? Please tell me.
Guys, if you have any doubt, you can ask him, because you have paid for this workshop, so please take the maximum benefit of it. You have paid for this workshop, please take a maximum benefit of this workshop. Please clear your doubts from sir.
Sir, please explain this once, sir.
Yeah, simple ma. Do you know what is the square root? First of all, Jaya,
Sir?
what is the square root? You know.
Yeah, sir.
So square root of some number. When we are finding square root, suppose 36 is nothing but 6 square. Then we are finding the square root of this number. Then you are getting this one only, not the square. It is clear my point?
Yes, sir.
Yes, sir.
Listen, here I am not considering the square root. I am considering only this value. This value is nothing but 36 now. 36 nothing but 6 square only. Am I right?
Yes, sir.
Yes, sir.
In the question, he will consider root value and he will give only answer only. But we are taking this value, then we have to find the square of this value. Then only it is matching, I am saying. In the question, he will give like this, but we are changing like this. Clear, Jaya?
Yeah, sir. Clear, sir.
No, it is clear or not?
Yes, sir.
Anybody have any doubts? You can ask me.
No, sir.
So this is the digital root. We are going to use digital root for the verification.